So we're here at the example table, and in this video we're going to rewrite some functions in a piecewise way, namely absolute value functions. So let's just recall the definition of the function absolute value of x. Intuitively, it leaves positive values alone, leaves 0 alone, and switches all negative numbers to their positive counterparts, right? So 3 stays the same, 0 stays the same, negative 5 becomes 5. And we can rewrite this in a piecewise way like this. So absolute value of x is just plain old x if x is greater than or equal to 0. And it is negative x if x is less than 0. Right, so notice here, if x is less than 0, then negative x is a positive number. Right, so this is the piecewise way of defining the absolute value. So what if we want to rewrite the function absolute value of 2x minus 3? If we want to rewrite this as a piecewise function, well, the simple way of doing it is simply to say it's equal to 2x minus 3 whenever 2x minus 3 is greater than or equal to 0. Right? We just essentially copy this first line from the definition of absolute value, only in its place we put 2x, in place of x we put 2x minus 3. What about the bottom row? Well, if 2x minus 3, let's put the condition in first. If 2x minus 3 is less than 0, then we want to multiply it by negative 1. And if we multiply it by negative 1, it just switches the order here. Instead of 2x minus 3, it becomes 2x minus 3 becomes 3 minus 2x. There we go. That's the quick answer. The only thing that we might want to do is rewrite this condition a little bit more nicely. Just say x is greater than or equal to, or x is less than, something like that. So 2x minus 3, if we do a little work, we'll find out what that should be. So 2x minus 3 greater than or equal to 0. So 2x greater than or equal to 3. Divide both sides by 2, we get x greater than or equal to 3 halves. All right, so just a little work on the side here. So then we can rewrite this expression as 2x minus 3 if x is greater than or equal to 3 halves, and 3 minus 2x. We do the same thing, only we switch all of these to less than symbols. We get x less than 3 halves. And that's how we can rewrite this function piecewise. Let's do another example. So let's look now at the function f of x equals absolute value of x plus 1 minus 3x. It's a little bit more complicated. Let's start. What's the thing that's going to change? Well, the minus 3x isn't going to change, right? It's this part with the absolute value. So if we write the two cases, in the first case, we're going to leave x plus 1 alone. So we get x plus 1 minus 3x. We'll worry about what comes over here in a second. In the second case, we're going to multiply what's inside the absolute value by negative 1. So we get negative x plus 1 minus 3x. Now, what are the conditions that make each of these happen? The only thing that's in the absolute value is the x plus 1. So this first case holds when x plus 1 is greater than or equal to 0. The second case holds when x plus 1 is less than 0. So now we're done except for some simplification. In this first case, we have x minus 3x, so that gives us minus 2x. and then plus this 1. Second case, we have minus x minus 3x, so we get minus 4x minus 1. And then these conditions we can also rewrite like we did in the previous example, only it's even easier here. We just move this plus 1 to the other side. So on the top we get x greater than or equal to negative 1 and x less than negative 1. And here is our piecewise version of our original function